Hello, everybody. My name is Dima, and I'm working here in Heureka in feed processing. What it means that we just downloading data from the e-shops, parsing them, and storing them, and sending for other services to process. So today I will talk to you about profiling your applications to find bugs and improvements. So we will go through what is profiling, what is pprof. I will show you some small demo, how it looks like, and we'll share with you some real case scenario, how we used it and how it helped us. So what is profiling? So profiling is a way of analyzing your program performance by measuring, for example, usage of CPU or memory for some parts of your code, or for example, how often does some function is called, or how long does it take for a part of program to be executed. So most of the times it's done by instrumenting your code or executable. For example, you can just import library and the library will do some magic for you, or it could be kernel level tools like Linux perf or this Orbit from Google, which looks at intercepts like kernel calls, and you can also do some profiling from this. So now let's look at profiling and Go. So there is one common instrument which is used for profiling is pprof. And there is a lot of, it produces data, but it's not very human readable. So some visualization tool is required. So there are several of the visualization tools. For example, GCP Cloud Profiler, Grafana Periscope, and pprof, which goes like included in your Go toolchain. Today we will look at pprof, just because it's always at your hand and you can always use it. Yeah, and for example, cloud solutions can be used for continuous profiling. So for example, you can measure your application performance between releases. Could be really useful. And now moving to pprof and how it's used with Go. So pprof actually is twofold. One is the thing that produces your profiles, and another one is there's also like the second one is you have pprof HTTP server which you can ask for profiles, and another one is visualization that shows data in human readable format. And the easiest way to start with it is just import net HTTP pprof, and it will create you default HTTP server which stores profiles. And using pprof tool, you can download these profiles and just visualize them. So when after you add some import this library into your code, and you go to index page, this is you can see lots of available profiles. So first one is allocations. It's show you allocation your app made from the start of the profiling. So most of the time, if you include HTTP server, it's going to be from the start of your application. Blocks, it shows what blocks your application. Command line is just name of the application. Go routines, it shows you current go routines that can be used, which can be used to check how many go routines you're currently running, or also can be useful, very useful to find go routine leaks. For example, that you create some go routines, but it never closed. Heap shows you heap profile, can be used for finding memory leaks. Mutexes, it shows you what hold your logs. It can be used to see contentions. Like for example, something takes a log on a common resource, but another part of the application just waits for it to release it. And you can just actually find why your application just waits and does nothing. Profile, it just starts and run a CPU profile for 30 seconds by default. It can be configurable, but it shows like what eats your CPU cycles. thread create, it shows Go routine OS threads created by Go runtime. So actually in Go, you don't manage threads, but Go runtime manages them for you. So and you can check here like what caused Go runtime to create more OS threads. And trace shows you lots of traces for your application, like kernel calls and lots of different stuff that I don't actually understand. And a small note, it's like allocations at the heap are providing the same data. It's just like default view on this data is different. So if you can actually click on these individual links and you will download this data in text format, it's not very like understandable, but you can look at it, but it will be really hard to understand. So how you can run visualization? So first part is like the application itself. It's go to pprof. The second one, first argument is HTTP. It's you're saying for this tool to run your web server on this address, like web server with the interface on this address. And the last part is where to get profiles. It can be HTTP server, or it can be just your local downloaded, some local profiles downloaded to your computer. And the last part is actually asking for a heap profile. And yeah, and now we are moving to the part where everything probably should go wrong. So I will show you some application. And okay, I'll show you some applications how this profiling will look like. Okay. It's going to be hard with one hand. So what we have here is a small web server. So first line here, like first interesting thing here is just importing pprof to default server. And here we're creating just a small server that listens on port 8080. And what it does, it actually reads body of request, and puts it into this do work function. And this function creates Go routine, and it just waits for something to read from the channel, but actually nothing reads from this channel, so it blocks forever. So here we will have Go routine leaks, and we will have memory leak. So for each request, it will just spawn Go routine and read the data from the request and just store it in memory. Now, so I will run the server. Oh, thank you. So currently I'm running the server. Let's make some requests for it so we can at least start to see something. And now let's see. Here I'm asking from the server some profiles, and it will just open you in default browser some UI. Actually, we don't still have anything. Just a moment. Let's make some requests. Okay. Now we have something here. So this view is like a call stack. This is currently our application showing 900 kilobytes of memory. This is one of the views of the data. Like the bigger the rectangular, the more data it eats, the more data it needs. So it's like lots of call stack. But I don't find this view very useful. Okay, the top one. It just show you again the call stack, but ordered but what eats the most. Next one is frame graph. There's like actually two of them. This one I like more because it UI a little bit better. So this one shows you actually what application eating almost 1 megabyte of memory. Also, you can change the view of the data. For example, you can take a look at allocated objects. So actually, from the start of the application, we allocated only one object. Allocated space. Again, from the start of the application, we allocated 800 kilobytes. And in use, it's like how much currently we are using. And in new space, again, how much currently it's used. And this is because nothing actually happens current. It's used from the start of application, it used the same memory and objects. Now here you can see the call stack. Yeah. Let's run some. I have some more small script here. What it does? It's actually just send this big file. Big file is just 1 megabyte of blob data to the local host, to this server running here, and that's it. So let it run for some time, and we will see how something will appear. We will see some memory leaks. And let's ask for some profiles. Now we can see that application ate like 800 megabytes, and still so. If we go here, so here we can see the call stack, how much each memory ate. So it's currently in use space. And here is a small call stack. Also, the nice feature here, you can also right-click here and show source code. This is like some internal source code. We don't actually need it. Let's go here. Yeah, this one actually shows that it ate like 99% of the memory, and this was this line. It's when we read some body of the request, and it ate like lots of memory. Yeah. And let's also take a look at coroutines. So currently we have like 900, almost 1,000 coroutines. Let's go here, take a look. So root of the application have 9,094, and like this one, do work, actually found 990 of them. And we can check a look here. This is like where it was found and what it actually does. It's blocked here. So we can actually assume that somewhere here we have a coroutine link. Yep. And that's probably it for the live part. Thank you. And I will move to the presentation. So, and some real case scenarios that we had. And I will just show you how we improved our application with a small fix and with the help of pprof. So we have an application that reads data from RabbitMQ, manipulates this data, and write them to another RabbitMQ. So for those of you who don't know what is RabbitMQ, it's just a message broker. So in other words, you just send it a message and it routes it to another service. So once upon a time, our application got OM killed. That means that application was out of memory. It couldn't allocate more, so it dies. And we started investigation. First thing was that we added pprof, and we will see what it show. So on this graph, you can see that our application was eating like it's in allocated memory. It's 90 megabytes, and like 70% of it is actually RabbitMQ client. This bigger line is showing you that application was eating messages from RabbitMQ and doesn't free the memory. It was just storing them inside. And what our graphs shows us that garbage collector was collecting a lot of memory. You can see that the first graph is actually showing like how much memory would garbage collector free on the next run. So it ate like, you don't see it, but it ate like 450 megabytes. And on the second image, you can see number of GC runs per second. It was almost doing nothing, this lazy bastard. It was doing like 2 operations per second. And this abruption, this is actually the moment of death. This is actually the saddest moment of this application. And what actually helped us is setting up environment variable go memory limit to 100 megabytes. So what it actually does, it tells garbage collector to try not to go over 150 megabytes of memory usage. So if your memory usage application goes to this line, it will stop the application and free up the memory. Yeah, there is so small drawback of it because of nature of how garbage collector works. It will freeze the application, but it's much better than like application suddenly dies. So after the fix, you can see application eats much less memory, and the RabbitMQ client actually uses much less memory. And on this picture, you can see that actually garbage collector collects only about 20 megabytes of memory, like constantly, and it actually started to work around like 10 operations per second. So with a small fix and the big win for us. Yep, that's actually it from me. So if you have any questions, you can ask them now. Also on the slide, you can see some good sources for pprof. And the last one is actually a really good article about garbage collector. It has nice animations. You can play with them and see how garbage collector in Go works. That's all from me. Thank you.